Have you ever noticed that two buildings using the same voltage level can have completely different levels of electrical safety? You might install the best circuit breaker, the best cable, even the best electrical panel. But if the earthing system is poorly designed, a single insulation failure can turn your entire installation into a shock hazard. And here is the truth. Many engineers on site work with earthing system every day without fully understanding how they actually differ. Well, in this video, I'll break down TNS, TNCS, TT and other earthing system in a simple and practical way. We'll start from the less safe arrangement and move towards the safest one, so you clearly understand what changes and why it matters. I'm taking this lesson from my course on low voltage switchgear. If you want to know more about the course, I've given the link for it down in the description. You can go and check it out. Let's start with the basics. Before we jump into the system, you need to decode the letters. Now these letters follow IEC classification. First letter tells about connection of power system to earth. So T means terra, which is direct connection of source neutral to earth. I means isolated. Source is isolated from earth or connected through an impedance. Then let's talk about the second letter. It talks about connection of exposed parts. For example, connection of a frame of a medium voltage switchgear panel. T means exposed conductive parts connected to a local earth electrode. That means you have a local earth pit and you are connecting everything to that locally. Then we also have N. N means exposed parts connected to the supply system neutral. From the supply side, you have got a dedicated conductor for earth and you have connected the exposed part to that conductor. Here, no local earth electrode is involved. Then we also have some additional letters like C. C means combined. So in that case, neutral and protective earth combined in one single conductor called as PEN. Then we have S. S means separate. Neutral and protective earth are separate conductors. So when you see the letters like T, N, C, S, it's not random. It's literally describe how the system is grounded and how protective conductors are arranged. Now let's start with one of the least safe configuration of earthing system. So first is TNC system. First let's decode the letters here. The first letter T, which means the source's neutral is directly connected to the earth. The source can be generator or a transformer. The second letter indicates that the exposed parts are connected to the supply system neutral. And then we also have an additional letter C, which indicates that the neutral wire or earth wire that is coming from the source is combined as one. In a TNC system, neutral and earth are combined into a single conductor called PEN, protective earth and neutral. So instead of having separate neutral and earth wires, you have one shared conductor. You would have seen PEN marking on many of the single line diagrams. Now this system is risky. Why is this risky? Let's understand. Because if that PEN conductor breaks somewhere upstream, that means nothing is wrong at your end, but conductor has broken near to the source. But still the metal body of your equipment can become live because it's one single conductor. Now let me give you a real world example here. Imagine a small workshop connected to a transformer using TNC system. A loose connection happens in the PEN conductor at the pole where the electricity is coming from. Now the motor body, panel enclosure, even the metal casing of machines can raise to phase voltage. And that's very risky. Touch it and you complete the circuit. This is why pure TNC systems are generally not permitted inside the buildings. They are sometimes used in distribution networks to reduce the conductor cost, but not recommended inside installation. Yes, the distribution company will save the cost with this because you only have one conductor for neutral and earth, but then you're also adding risk to it, a lot of risk actually. The main issue here is no dedicated protective conductor. If the combined conductor fails, the safety also fails. Now let's move slightly safer to a system which is safer compared to the TNC system. In a TT system, the source neutral is earth, which is the letter T, first letter. same as that of the previous system we talked about. The installation's exposed parts are connected to a separate local earth electrode, again the letter T. Here, the consumer has their own earth pit. The system is very common in rural areas and small standalone buildings. Again, let me give you a real world example here. A farmhouse or a rural house supplied by utility. The utility provides phase and neutral, and homeowner installs an earth pit and connects all the equipment bodies to it. Sounds safe, right? But the problem here is fault current. In TT system, when a phase touches the equipment body, the fault current must flow through earth soil back to the transformer neutral. So the fault loop impedance is high. And as a result, the fault current may not be large enough to trip the MCB quickly. That means there is a possibility that there is a fault in your system, but the MCB is not tripping because the fault current is not high enough because of high impedance. And that's why the TT system heavily relies on RCCBs, residual current circuit breakers, for protection. If the RCCB fails or is bypassed, the system becomes dangerous. So compared to the TNC system we talked about, TT is safer in terms of no combined conductor, but it depends strongly on RCCB protection and soil resistivity. Because even if something is wrong with the earth pit, that's not good, right? So now let's move to a system you will see very commonly in modern installations. So now let's talk about the TNCS system. Now the first two letters we understand, we also know what they mean. Now here you will see we also have two additional letters, C and S. That means the neutral and earth conductor are combined and also separate. Let's understand what does this mean. The two letters that you see, C and S, that means from the transformer to a certain point, neutral and earth are combined. That's why you see letter C. After that point, they are separated, letter S. This is called PME, protective multiple earthing. Here is the real world example. In many urban residential societies, the utility supplies a PEN conductor. At the service entry point of the building, neutral and earth are separated. Inside the building, you now have separate neutral and earth conductor. Why is this better? Because inside the installation, you now have a dedicated protective earth conductor. If a phase touches the equipment body, fault current returns through a low impedance metallic path, not through the soil. So protective devices like MCBs trip faster. However, there is still one concern. If the PEN conductor breaks before the separation point, dangerous touch voltage can still appear. So TNCS is safer than TT in terms of fault clearing speed, but still has upstream dependency. And by the way, if you're enjoying this breakdown and want more practical explanations like this, especially concepts that actually help you on site and in interviews, make sure you subscribe to the channel. I regularly post videos that help you practically. Now let's finally get back to the safest system, the TNS system. In TNS system, neutral and protective earth are separate conductors from the transformer itself. There is no combined PEN conductor at any point. Here is the real world example. Large industrial plants, data centers, hospital, these often prefer TNS system. From the transformer secondary winding, one conductor is neutral, another completely independent conductor is protective earth. Now, why is this safest among the TN system? Because there is absolutely no risk of combined conductor failure. Fault current returns through a dedicated low impedance path. Protective devices operate quickly and reliably. Touch voltage risk is significantly reduced. For critical installations like operation theaters or sensitive industrial control system, TNS provides better safety and electromagnetic performance. Cost-wise, this will be expensive because we will be adding a dedicated conductor from the source to the load. And the distance between these two could be hundreds of kilometers. Now there is one more system worth mentioning briefly, the IT system. In an IT system, the source is isolated from earth or connected through high impedance and the exposed parts are earth. Now, where this system is used, it can be used in hospitals, mines, and critical process industries. The question is why? Because in an IT system, a single phase to ground fault does not immediately trip the system. This ensures continuity of supply, but it requires insulation monitoring devices to detect the first fault. It's not common in general distribution, but definitely critical for uninterrupted power applications. So here is the quick comparison. If we rank from the least safe to the most robust system, then is the TNC system, highest risk due to the combined conductor. Then we have TT, safer but depends on RCCB and soil condition. Then we have TNCS, good balance, widely used. Then there is TNS, best standard practice for safety and performance. And then we also talked about the IT system, which is best for continuity but specialized in application. So earthing is not just about connecting a rod to the ground. It defines how the fault current flows, it determines how fast protection operates, and ultimately it decides whether a fault becomes a small trip or a fatal accident. As a young engineer, if you truly understand earthing system, you immediately stand out on site and in interviews. Now, I've done a couple of videos on how grounding is done in a substation. If you're interested in knowing that, you'll get link for that video as well down in the description. Definitely go and check that out. If you found this video helpful, then do like this video and do share it with the people you think might be benefited via this video. Thank you so much for watching, guys. I'll see you in the next one. But till then, keep watching, keep learning.